angular momentum of system of particles. So if we consider we have a system of particles where total number of particles is n, we can select for deriving the desired laws one representative particle mi. So let's consider that this particle has some displacement, and we measure this displacement by means of displacement vector Ri. So Ri is a displacement vector of particle. This origin of coordinate system we can consider as a reference point. So this is a origin of coordinate system, origin of coordinate system is so-called reference point or point of reference. And let's consider that this particle is moving with velocity vi. Okay, so then momentum of ith particle is pi equal mi by vi. Okay, and angular momentum of ith particle is, let's denote it L. Li is equal Ri by pi, and angular momentum of the system of particles is given by summation, sum over I of these equations. So we have here n equations from 1 to n, and we sum it all together and we get L, total angular momentum, is given by sum of Ri by pi over all I. So it means that it is sum of Ri by mi vi over I. So we can talk about total angular momentum in the reference to that point of reference. Okay, so if we choose another point, this value or vector will be different. And now we can make a derivative with respect to time of this equation d over dt, and we get change of angular momentum in time. So it is dl over dt is equal d over dt by, not by applied to this sum. So of this sum, so it is Ri by mi vi I over I, and we can multiply this. So we can apply this derivative into this to this multiplication. So it's a sum of dr I over dt by mi vi plus sum of ri by mi dvi over dt. Now we can make a short analysis of this result. So dr over dt, it is a time derivative of displacement vector, what is nothing else than nothing but velocity. And if we multiply by vector multiplication, the vector of velocity by vector of velocity multiplied by scalar value, so maybe it is like this. So this is a vector mi vi. These two vectors are collinear, vi and mi by vi. Okay, because mi doesn't change vector properties, only size. So we know that vector multiplication of two collinear vectors is 0. So vector vi is collinear with vector mi vi, and from that follows that this multiplication vi by mi vi is equal 0. Okay, so this is 0. Plus r, we keep it as it is, by, and there is derivative of velocity of a particle with respect to time, what is an acceleration of ith particle, and mi by ai is external force acting to ith particle. And finally, we can write, so m by I is, from previous calculation, it is sum of forces acting to that one particle, so it is a resulting external force plus sum of reactions from other forces. Okay, so we get subsequently that the sum of ri by mi ai is equal sum of ri by this, what we said. Okay, it is a sum of external forces acting to particle I plus sum of all internal forces, because other j particles are acting to particle I. So we can multiply it, so it is sum of ri by fi plus sum of ri by sum of fji. Okay, previously we said that if sum of reactions between our particle and other particles is equal 0, so the moment of these reactions is 0 too, and this is an external moment of external forces. Okay, so applying this, we get the law which says that dl over dt finally, so let notice here we started here, so I repeated here, is equal me. So this is a law of change of angular momentum and in brackets I can say in differential form. Okay, it's a differential form. Okay, and we can rewrite it also to integral form. So we can write that if we integrate this, so we get dl, the integral from L1 to L2 is equal integral of m external dt from time 1 to time 2. So we get from this L2 minus L1 is equal integral of m e dt from time 1 to time 2, and this is integral form of this law, differential and integral form. And from that we can derive a law of conservation of angular momentum. So under the consideration that this integral of me dt, this integral is equal to 0, so consequently L2 minus L1 is equal to 0 and L2 is equal to L1. So the angular momentum at state 1, it means original state, is equal to angular momentum at state 2, final state.